Hey, I guess you're pretty proud of yourself now. You've come to the end of the statistics journey there. And all that remains is to do some practice questions and check the statistics syllabus there to see if we've covered everything, if you're up close and personal with it all. Have a look around the screen. Isn't this a nostalgic journey here? We've done all these things, starting with, of course, a set of data and all the different things we've tried to do with it in this section on descriptive statistics. It's been a fantastic journey and well done for coming this far. Let's have a look at the statement of the syllabus and see the little ins and outs there that we must check. Okay, so this is the IB standard level new syllabus, first examined in 2014, and this is from the statistics and probability section, and I've split that into two. We've only done the statistics part of it. So here we are, let's have a look. We're introducing basic concepts. Yep. And most of the calculations, most of them, will be done using technology. Okay, so it'll have to be paper 2. But explanation of calculations by hand may enhance understanding. We've done a bit of that. The emphasis on understanding and interpreting the results obtained. Look out, here's an important word, in context. So there are practical applications, and Pearson's have provided us with a lot of good ones there, showing you not just to calculate the mean of numbers, for example, but to set them in the context of maybe the mean number of euros spent, if you remember that example, by students. Okay, statistical tables no longer be allowed in exams. You wouldn't know anything about those. We don't use those anymore. Many of the calculations required are estimates, because data's been grouped and things like that. However, it is likely that the command terms, what they command or instruct you to do, write down, find, and calculator will be used. And so I've taken these, I've taken these from Pearson's list of command terms. You've got these. If you look at these booklet I provided for you, scanned on assessment. Okay, at the back of that are the command terms. Let's read them now. Write down. Obtain the answer usually by extracting information. Little or no calculation is required. Working does not need to be shown. It's very important. In other words, you're expected to spot something there, not to do half a page of calculation. So don't miss the point there. Find. Okay, the next one is find. Obtain an answer showing relevant stages in the working. So you will not get full marks just for the answer there. There'll be a reasoning mark or a method mark or both. Calculate. Obtain a numerical answer. A little bit different from find. Show, but the same idea here, showing the relevant stages in the working. So there'll be a reasoning and method mark, but there'll be a number answer, whereas in find it could be anything. It could be a formula or something like that. Okay, let's have a look at the actual syllabus now, and I want to bring up some of the things that have come up during the course. Concepts of population sample, random sample, discrete and continuous data. All right, the distinction between those is going to be made. You're going to have to know that. Okay, frequency distribution, frequency histograms with equal class intervals, you've done that. Box and whisker plots, outliers, know the definition over here. More than 1.5 box lengths from the nearest quartile, IQR in other words. Technology may be used to produce histograms. Okay, and box and whisker plots. So they're probably not going to ask you to group the data by hand. It takes too long. Okay. Group data, use of mid-interval for calculations. We've made a big point of that. If you've lost the actual data and it's grouped, how can you estimate means and things in calculations or even standard deviations? You will use the mid-interval, the midpoint of the group. Okay. Modal class, one that occurs most frequently. Okay, so that looks good. Let's come down here now to the next couple of sections. Statistical measures and their interpretation. Central tendency. Okay. Quartiles, percentiles. Okay. Here's an important point. On examination papers, data will be treated as population. Okay, so you use your sigma on the calculator for standard deviation. Taking the group as a whole population, not as a sample. You don't lose those degrees of freedom with n take 1 in the denominator, if you remember that. Calculation of mean using formula, directly by hand and technology. Students should use mid-interval values to estimate the mean of group data. That looks like that's going to be an important point, doesn't it? Mentioned a couple of times now. Calculation of standard deviation of variance using only technology. So you don't have to do all those calculations that Pearson's have shown us so well. You don't actually have to do that, but it shows some understanding of what you're doing. Okay, dispersion, range, interquartile range, all as measures of spread or dispersion. And remember, some resist skewness, some don't. Effect of constant changes in the data. So that was a little section on the end of, I think, the last pod, the one on the measures of spread, that video. Okay, so here, linked to transformation. So in other words, if you take 5 away from every score, you're translating the function, thinking of that. And here are the couple of examples that you might think about, which we covered in that. Applications over here, well, we did most of those using Pearson's examples, and they were all applications, weren't they, to mean euro score or cost for per week for those students and so on. Okay, let's go on. This has always been a favourite down here. Cumulative frequency graph used to find median, quartiles, percentiles. Okay. Values of that produced by technology may be different from those obtained from a cumulative frequency graph. We talked about that to some extent. Because of the cumulative frequency graph, you've lost the original data and you're drawing a curve by hand. There's lots of aspects there that are prone to error. Okay. Are you happy with this? You remember all this stuff? Okay. Here we go. The last section then, linear correlation of bivariate data, how much they're associated, the idea of independent variable being on the x-axis, dependent variable being on the y. Even if it's not called x and y, they are the axes that you will put them on. So independent variable on the horizontal axis, dependent variable on the vertical axis. Labelling the axes carefully with the contextual variable here. So the independent variable might be, for example, time in hours. Label that on the axis. Dependent variable might be distance in kilometres. Something like that. It must remain in context. That's mentioned right at the beginning of this section. Technology should be used to calculate R. You don't have to do it by hand. You can see it, and we talked a little bit about that, by R, calculations of R by hand, but to understand it, not required. All these, can you tell when there's a correlation which is positive, 0, negative, strong, weak, no correlation? Okay, scatter diagrams, lines of best fit, must go through the mean point, x bar, y bar, because that's a result of the formula, isn't it, for the least squares regression approach. Technology should be used to find the equation and interpolation and extrapolation. Equation of the line, use of equation of prediction, mathematical and contextual interpretation. Like what is the meaning of the slope, for example, of the line, the number in front of the independent variable, 3x plus 2. It means if x increases by 1, the other independent variable, the dependent variable, increases by 3. That sort of thing. Okay, mathematical and contextual interpretation. So, what's that, 3 units? It could be 3 kilometres, something like that. So you've got to put it in context. We did a little bit of that. Not required the coefficient of determination, which is r squared, but handy, isn't it, to think about the impact of the association on the variation in the variables there. Okay, let's go down and have a look. We'll just get over here. Okay, so let's have a look at question 1. Here are the set of practice questions. 1 and 2. Now, I'll put the solutions right at the end, so when you finish one, you'll just scroll up and back again. 1 and 2. Have to pause it as we go. Now, coming up to 3. That's right, yes, we've got all of 3 on there now. Okay. 4. Can we get 4 on? I'm not sure. That's 4. I think there's another part for 4. Yep. I have to pause it and go back and forth, look at the graphs. Go to 5 now. Okay, they put the box plots vertically, you read it the other way. Not a problem with that. Read the scale carefully. Go to 6 now. And let's have a look at 7. I think there's about 26 questions. It's a good summary. And when you're doing this, you should be trying to pigeonhole the question into a section of the syllabus. Okay, that's the idea of looking at the syllabus up there. Question 8, I think that fits in there just. Let's sort of look here. Yep. Okay. Let's just go on to 9 there. Yep. Rest of 9. Just notice here, I hadn't seen this before. That's not required. Calculate showing all work the mean and standard deviation of the data. The mean you could, the standard deviation is not required in the syllabus, as we just saw. Not by hand. And 10. Okay, down to 12 here. Can we get it all on? Not quite, I think. Oh, it might only be A and B in 12. There's a bit more here. Let's bring 12 up. There's all of 12 then. So 13. 13 and 14. $15. $16 now. Most of 16, some of 16 is still coming up. Rest of 16. 17 now. What have we got there? All of 17, can we? No. Most of 17. Coming off the rest of 17 here now. So read as we go, big graph here. Okay, there's a graph you need to answer that question. And come to D. D and E. Go to 18. A, part of B. The rest of B. Okay, C. So look at 19 now. I'll bring the graph up, because you're going to have to come back to this. There's the graph. There are the questions A, B and C needed. So I have to rewind and go back up there. It was too big to fit on one screen there. Got 20, 21. Can we fit? No. A little bit of 21 still to come. There's just 21. Two now. Part of 23. Go to 23. See if we can get the whole graph on. You have to come back. Complete the frequency table, so that's not ideal. To copy the frequency table down, then come back and do it. Okay, 24. Five. Interesting little question. They've asked this in the past. I think actually Pearson's here give credit for the number 13 to 26 questions coming from the IB. I think I've used them in past papers. The last question I think now is 26. And there we have it. You see down the bottom here, that is from the IBO, 13 to 26. It gives you a good idea of what they ask. Okay, so there we have it. Some good questions there. Now I'm going to scroll down to the answers. We'll just go through the answers now. 1, 2, and part of 3. Check your work carefully. Let's see, we get all of 3 up there. Down to D. Keep going. E and F. Let's look at question 4. Down. I'll come down and do D in a minute. See if we can go to D and F, yep. Okay, let's go to number 5. 5, 6 there. Part of 7. Let's look at the rest of 7. Make it 8 now. Check your box plots there. Question 9. I don't think we can get all of 9 on. There's the rest of 9, E and F. Go to 10. See if we can get it all on. 10A, B and C. Then D and E. Let's look at 11 and 12. Thirteen and 14, not all of 15. Have a look at the rest of 15 then. Go to 16. There's part E down the bottom now. There's 18. See if we can get it all on. Yep. $19. $20. Come down a bit there. 21, we've still got E to come on 21. There's E. Row 22. 23 there. Last three here. 24, 25 and 26. Okay. Well, how did you go? A lot of work there. If you can do those 26, you're doing well here. So some of those are fairly extended questions for this course, only standard level course here. So get that ready because 9 months away you'll be sitting an exam, or 12 months away you'll be sitting an exam, and that's a fair workout. Those 13 to 26 come from the past papers of the IBO. So have a go at those particularly. Okay. I hope you've enjoyed our statistical journey. I hope you have a much better understanding of what statistics is about. And what are we going to do next? Well, we're going to journey into probability. It's a nice flow through from statistics and probability. You'll find in most texts they have the title Statistics and Probability, and we're going to find out why. What's the connection between probability and statistics? Anyway, I'd like to catch you a bit later on talking about that. But for now, it's cheers from Huddy.